In the first two examples, we want to take a look at finding the limits of a function at jump discontinuities. In this case, we can see with example 1, we have a point of discontinuity, a point where we'd have to pick up our pen or pencil to continue tracing that curve. We have a jump discontinuity because we jump from one y value down to another y value. And we have some limit questions that we want to answer. In this case, we're going to look at the one-sided limits as we approach -3 from the right and from the left. But ultimately what we're interested in doing is answering a question about what's happening as x approaches -3. There are different ways to go about doing this, but what we want to do is just somehow indicate to ourselves that we're interested in what's happening at x equals -3. We could highlight that value, we could highlight the vertical space that passes through there, but something to focus our attention so we know what we're looking at. And then we'll look at the one-sided limits. In part A, we want the limit as x approaches -3 from the right. So we'll trace along that curve and just see what function value we're approaching. In this case, -3. And then we'll approach -3 from the left, which is what we're asked for in part B. In this case, we're approaching a function value of 4. Then we're asked to state what the limit is as x approaches -3. Again, our two one-sided limits are different. So we would say D and E or does not exist. The next thing that we're asked then, or the final part of this problem, is to evaluate g of -3. To do that, we look at the function in line vertically with x equals -3 and look at where we have the curve passing through, or in this case where we have a filled in dot. So in this case, we have a point defined at x equals -3, y equals -1. So our function value at x equals -3 would be -1. In example 2, we have a very similar looking problem. So similar, in fact, that it would be really easy to quickly get this problem wrong, because if we pay attention to the limit questions that we're being asked, even though the picture kind of draws our attention to that jump discontinuity, we're actually being asked a question about what's happening as x approaches -2. Meaning we're concerned with all of the vertical space in line with x equals -2. So now what we want to do is plot that point to, again, just draw attention to it. So where our function value exists at -2. And then consider the left and right hand limits. First we'll consider the right hand limit. As we approach -2 from the right, our function value would be -1. As we approach from the left, we're also approaching that function value of -1. Since the one-sided limits are equal, then our function has a limit of -1. And in this case, our function value itself is also -1. So with some of these questions, we'll be investigating what's happening at that discontinuity. In other cases, we're considering some other point. We just need to make sure we're paying close attention to what those limit statements are asking us to investigate.